Thank you very much, Peter. So this is an example of just-in-time delivery of machine learning. Thanks very much for waiting, guys. I was doing a bit of background research for this talk, and I read a blog post that gave 3 different characterizations of the perspective people have on machine learning. So the first was a mathematical perspective, which is all about understanding the mathematical models and optimizing those models and that sort of stuff, and taking it from a very mathematical viewpoint as opposed to trying to apply any semantics to it. Another characterization which excites a lot of people and scares a lot of people as well is the cognitive one, which is you see machine learning and the advances as being yet another step on the way to full-scale artificial general intelligence. You can get into all sorts of fantastic discussions, philosophy of mind, all that type of stuff. And I'd encourage you guys, Peter, to get a speaker from UCC, from the philosophy department, to come in and have a chat about all that stuff. And then the third one is the engineering perspective, which is the perspective that I would have, and it's the perspective of this talk. And we cheat. So we regard a lot of the machine learning toolkits as magic boxes. They do wonderful things for us, but we don't really know how they work. For you in the audience, for you if you're a person who does understand how the magic boxes work, that's fantastic, well done. It's pretty hard. I sort of understand them a little bit, but not too deeply. This talk is about understanding how people put them to work and the engineering applications that are now starting to become possible and much more commonplace. So this talk is about how my startup is using an old search engine called vespa.ai, which has been around and in development in the Yahoo engineering group for the last 15 years. Now that Yahoo is being split up into all sorts of different pieces, SmugMug just bought Flickr, for example, they're starting to also open source some of their underlying technology. And we're very lucky to get this piece of kit, vespa.ai, which only came out about 6 months ago. But it kind of dovetailed with something that I was doing around search for my startup. So it has a number of really interesting features that let you use the machine learning models that you build, particularly the output of things like TensorFlow, to give really, really high quality search results. So I just want to put it into the context, because if you're an engineer building the tensors, this is a way to use them really effectively, particularly with reading, which is the engineering challenge that vespa.ai solves. So just to give you a bit of background on the software itself, it was only open source in September 2017, and I started my startup in September 2017. So, you know, startups are all about taking risks. So instead of using Elasticsearch, which is the obvious thing to do for a search engine, we decided to use this. But the reason is because it gives the promise of this higher quality search results, and because it does this with really, really low latency. It actually is the recommendation, powers the recommendation engine behind things like Flickr and Yahoo News, sports and finance and all that type of stuff. The main Yahoo search uses Bing, but that's sort of a different application. What we're interested in here is not so much just ordinary search, but search that is relevant to the user. So search which is effectively recommendations focused on a particular user and built on the behavior patterns that you've observed for that user. So vespa.ai is really good at capturing user behavior in your system and then applying that to an underlying data set and giving you back results that are relevant to that user. like I said, it's really, really old. The code base is Java and C++ going back years and years and years. The good thing about that is that it means that you know it'll work in production. And in my experience, deploying it onto straight AWS, deploying it via Kubernetes onto Google Cloud Platform, it is totally unproblematic. You just need to give it loads of memory, and it's never going to fall over, and it works really, really well. I just want to put it in context. And again, this is, you might be working with tensors and TensorFlow and things like that in your day-to-day, but you have to put it in the context of a bigger engineering project, because there are many different choices when it comes to search. Choices that you can use for production deployments. The principal ones being Elasticsearch, which has been around for years and years. Algolia, which is search as a service, which is a really cool growth stage startup that you just plug into your site and gives you high quality search without any effort. Solar, which is also Java based like Elasticsearch and is the other alternative, or has been. And then just using a database, just using the search functionality of your own database. And finally, Vespa. So how do you analyze this? How do you make an engineering decision about which one to use? And of course, I'm painting a picture after the fact because I randomly chose Vespa because it was sexy and cool and could do machine learning. And this is the post hoc justification. The problem with Elasticsearch is the focus has moved to analytics. So Elastic, the company, makes money by selling a system, a toolkit for doing high volume analytics on large websites. Elasticsearch's search functionality hasn't really improved over the years. I used Elasticsearch to build a search engine for a newspaper about 5 years ago. And we were never able to get very high quality search results because it always came down to tweaking the boost factors on different fields. And that was about as sophisticated as it got. Also, the underlying algorithm in Elasticsearch is word frequency in a document, which is good enough for many applications, but we know we can do better now with machine learning. Algolia, really, really nice solution, but you've got to pay for it. So in some ways, and as an engineer, we often have this almost ethical quandary where if you're asked by the business what is the best solution, sometimes not building stuff is the best solution. And knowing about these options it's important so that you can make an informed decision. Solar is positioning itself against Elasticsearch as being highly configurable. I have never used it in production, but it's one of the other alternatives. Free text search on your database just works, and perhaps for many use cases, it's the right one to use. You probably already have a database, you don't need to worry about deploying anything else. And then, if you do want to use machine learning, as opposed to building custom infrastructure, as opposed to building a custom setup where you have to execute stuff yourself and you have to worry about performance, consider using Vespa because they've built all that infrastructure for you. You just put your tensors into it and away you go. So let's look at a concrete use case. This would be the use case which is my startup. So I'm building a social network for the conferences and events industry. And a big problem there is finding good conferences to go to, finding good speakers if you're running a conference, finding good venues, all that sort of stuff. So you can see how if I'm somebody who speaks about Node.js a lot, which I am, or microservices, or machine learning, getting recommendations for good conferences to attend in my locality or to speak at is something useful. There is a discovery problem in the industry. And if you think about all the different stakeholders in that industry, there's lots of people who have this problem. But these are lots of different types of searches. So if I'm searching for venues, it's probably because I'm a conference organizer as opposed to a speaker. But a speaker might search for particular conferences, but they might also be interested in meetups. So you've got, you can't just build a single search engine for the entire conferences and events industry. And if you go to places like Eventbrite, you can see that's what they do. The discovery problem isn't solved by Eventbrite because it's low quality search. It doesn't know who you are. It doesn't understand your needs. It just gives you back a bunch of events. Same with Meetup.com. Same with many of the conference and events directories. So we want to build something that's much better, that understands who you are and what your needs are. So these are the types of queries that we want to solve. And speakers for an internal seminar on microservices, Birmingham. Highly specific. How do you get Elasticsearch to do this sort of thing? It's actually quite difficult. And having built a search engine with Elasticsearch before, the reason I jumped on Vespa is because I knew answering these types of queries was going to be pretty tough. And indeed, I'll say it again, for this type of stuff, for high quality personalized search, current offerings suck. Free text search isn't going to cut it. If you look at some of the existing solutions, they force people to choose to parameterize their searches. So you have to say what location you want, that sort of thing. That shouldn't be necessary. And then they definitely don't have any personalization. So we kind of have to step back and think about how do we improve the quality of the results. And there's kind of two axes that you can think about this problem on. Precision, which is the number of results in your result set that are actually relevant. If I'm looking for microservices conferences and it throws me back a whole bunch of machine learning conferences, the result set has low relevance. Oh, sorry, it's got low precision because most of the results are not relevant. So you can think about this, you can quantify it by saying it's 1 minus the percentage of false positives. So if I return back a whole bunch of results, 300 let's say, and only 1/3 of them are relevant to the query, you can say that the precision is 0.33. So that's one way of thinking about the quality of the results that you're getting back. So if you work this back into the machine learning models that you're building, you can use this type of quantification to map that back onto the user experience. There's different ways of measuring how good your models are, but fit and all that type of stuff is much more of a mathematical perspective, whereas this is much more of the user experience engineering perspective. The other relevant axis is recall. So this is the number of relevant items in the results. And if you think about that, you can quantify it by saying it's 1 minus the percentage of false negatives. So this asks the question, how many things are left behind? How many things that should have been in your result set weren't? So if you picture that, the green area is the stuff you should have got. I should have got everything in the green box, but I only got half of it. And so my recall is only 50%. So you can see that this is not giving you a great result experience. What you want is a search engine that's going to give you high recall and high precision. And you can actually quantify that by measuring search results, query results against the known data in the system. And if you think about what Elasticsearch does, it's optimizing for recall. Everything that's got a high frequency of a certain word, throw it back. We don't care how relevant it is. And that's because it just uses word frequency as its ranking algorithm. What Vespa does is it tries to balance these two. So it tries to balance recall with precision. Because it has a much more sophisticated ranking algorithm. So ranking ultimately is just the order that the results are presented to the user, the order that they come back in from the search engine. And in one way, finding results in the database is not the hard problem. The hard problem is ranking the results. Having a ranking algorithm that gives you the quality that you need. And whereas something like Elasticsearch or Algolia is mostly based on word frequency, with Vespa you can add in much more sophisticated ranking. You can add in multi-pass ranking, and you can add in the machine learning models that you've built against the data set and user behavior. So how does that all work? I'm going to teach you to suck eggs now. I've been to a few of these meetups, so you guys know how this stuff works. Scalar is something that has one value. Vector is something that has two values, and tensor is n values in n dimensions. And you could visualize it like this, lots of little arrows in multiple dimensions going all over the place. Like I said, we're taking a magic box perspective of this stuff. So as an engineer building something that uses machine learning models using tensors, I don't need to even understand how tensors are made. I just need to understand that these are really useful data structures that do magic when I put them into Vespa. But I should understand the basics of how they fit together. Obviously, ultimately a neural net is just a tensor, right? It's just something that we model in this way. And Vespa is designed to take these data structures and work on them really efficiently. And the heart of the whole thing, the heart of the entire way that it works, how do I get recommended good conferences for me, is I have a tensor representing the user's behavior pattern over time, and another tensor representing the model's understanding of conferences or venues or speakers or whatever. And I combine them together in some way, maybe it's a dot product, maybe it's something more complex, to give me a rank. And it's essentially just matrix multiplication. And Vespa is really, really fast at it. But this is where you start getting some of the benefits of Vespa, because you don't have to start building out infrastructure yourself. One of the powerful things that Vespa does is provides you with a multi-pass ranking. So you can have a really accurate model, but that means you've got really big tensors, you've got lots of data, and if you've got millions of records and you're performing this operation against all the records, it's going to take a long time. You're not meeting the latency expectations of the user. You're not throwing back results in milliseconds. And Vespa, one of the core engineering principles was, let's get results back within 1 second, under 1 second. So the way you do that is you have multiple passes. You provide an initial ranking which is coarse, which is low grade, and that reduces your result set significantly. But it gives you a high recall because you're getting, hopefully, most of the stuff you should get. And then you do a second pass to get the relevant results, to rank the results in order of relevancy, which gives you high precision. And Vespa just provides this baked in. So you use TensorFlow, you build your models, you upload them into Vespa, you capture your user behavior as they... So, if I have a user in my system and they keep searching for machine learning and artificial intelligence, that sort of stuff, I want to be giving them back conferences about machine learning. I want to be showing them this meetup, for example. Essentially, that means I take the user's preferences, I take the popularity or quality of the items in my database. So this is a very high quality meetup. I want it to be high up in the search results. Anybody here who has gone to machine learning or artificial intelligence events wants to get recommended this meetup, so the two come together, and this should appear high up in the rankings. And that's it. From an engineering perspective, that's as much as I really need to understand, because my friends in the data science department will work out the models for me. But I need to know how to fit them all together and how to run Vespa. Perhaps I'm a site reliability engineer, something like that. But if you are somebody who builds models, it's also important to understand my perspective. This is the way that I think. I don't really care how you came up with all these arrays of numbers, but this is how I intend to use them. And that's the fundamental thing. If you're building a machine learning system, if you are consulting for a company and recommending ways for them to use machine learning, generate something useful, you may know how to use TensorFlow, but how do you actually generate something that people in the company or the company's clients can use? Vespa provides you with a ready-made solution out of the box, because you can give them something that will generate search results based on the models that you've built. And again, we'll just go back to those questions. You can see how all these different queries give back higher results if I know that this is a speaker versus an organizer. If I'm an attendee, I want to find conferences. And again, I look at the conferences that this person has attended, and that allows me to give them better results. If I'm a venue, I might be looking for audiovisual people. This query actually comes from a real example, right? So one of our clients is based in London but had to run an event in New York, and they were running around trying to find service providers in Brooklyn. How do you find them? The actual way they solved this problem was through their network and phoning around and asking people. But one of the things we want to do is people who hold events in Brooklyn who are based in New York are ultimately going to be choosing the better service providers that appear in more of the events. We may even have a 5-star rating system. That means that somebody in London searching using this type of query will benefit from the models that we built around the behavior of users based in New York. That's how we intend to use machine learning investment, put it all together. So on the practical side, the things to love about Vespa development are this batteries included philosophy. You've got pretty much everything you need for this problem space. It has a really well-defined extension mechanism, so you are not just stuck with its own ranking algorithms and models. You can add in your own. You can add in your own NLP stuff as well to handle queries. You can extend it in all sorts of ways. So if you're able to do a whole bunch of stuff in Java and C++, this is a ready-made deployment system. In fact, it's sort of an application hosting server. If you remember back in the day, we used to have WebLogic and things like that. This is the same mentality. So you can write code and it can be hosted within Vespa to run parts of your application, which is an old school way of doing things, but also really neat because it scales. So it's really easy to make this something that will handle any load. And it's specifically designed for integration with a lot of standard tools like Hadoop and Spark and things like that. So it's easy to get data into Vespa as well. You can hook it up into your data pipeline. Things that are not fun about development, it's very much Java and XML based, right? So you're not going to find too much JSON or any of the more modern things like YAML, that sort of stuff. It's pretty old school, but it is a 15-year-old code base. You do need to understand the basics. Right? You're not going to be able to build a recommendation engine unless you understand the ideas behind tensors, that sort of stuff. But the basics is enough. It is a big system. So I kind of jumped into it, got caught out a little bit, because if you actually go and look at the vespa.ai website, you'll see that the documentation is wonderful for an open source project. Fantastic. But there's tons and tons and tons of stuff. So it's not something to be taken on lightly. It has certainly paid dividends for us, and I would recommend it. But this is not something that you'll install and be up and running in a day or two. This is, for a senior engineer, a week or two of work to really get to grips with, at least another 3 or 4 weeks to really understand how you're going to deploy it and get it running. And we've gone through a whole cycle of running it directly on virtual servers in Amazon, which is a maintenance headache, to moving to setting up a Kubernetes configuration, which is less maintenance, but well, it's Kubernetes, right? So it's difficult to configure everything. So that's kind of a lot of fun. So it's not a free lunch by any means. On the operations side, it's designed for scale, which is fantastic, right? So you can just scale horizontally, as you would expect for something that does recommendations later. It has Docker images, so you can get up and running. You can run it on your machine pretty much straight away just by running the Docker run Vespa and up you go. So playing around with it is pretty simple. It's getting to the next stage of system deployment. That's the fun part. And like I said, full and deep documentation, which is really good on one side. The flip side is that's pretty much all there is. It's not like you can go to Stack Overflow and get an answer to any question. There is no admin GUI, which is kind of painful. So everything is basically curl commands, and you're getting back plain text from a HTTP endpoint. So that's kind of fun. Somebody should build one. It would be useful. It's pretty resource hungry. So you're not going to get away with spending less than $400 or $500 a month running this in production. And that's like the smallest level. And then, like I said, I think there's a grand total of 30 questions on Stack Overflow. There might be a few more now. That said, those questions are being answered by the actual maintainers. So if you go to Stack Overflow, you'll see that I asked a question, fairly detailed, and got a really cool response that helped me out. So small community, but it is being actively maintained. I was going to do a demo, but I'm not connected to the Wi-Fi. Is there much point? Voxgig.com, voxgig.com. Look at it on your phones, etc.
Do you want to
No, it's fine. It's fine.
Are you sure?
Yeah. So the search engine that we have deployed at the moment, this is where you should do a screenshot. The search engine that we have deployed at the moment doesn't do personalization because we don't have user accounts yet. But as people log in and start using our system, we'll start capturing user behavior and then using it to improve search results. So if you go to the site, you can see that even with generic search results that are the same for everybody, not only is it blazingly fast, but it also gives results that are really high precision and really high recall. And I'm way happier with Vespa than I ever was with Elasticsearch. On the same size of data, I remember spending 2 or 3 weeks messing around with Elasticsearch and boost factors trying to get decent results. With Vespa, plug and play. Relevant results straight away. And that's it. There's a few links to all the various things, including the Stack Overflow page and all that type of stuff. So thank you very much.